Hey, Greg here at Aemc Instruments. I'm our technical product trainer. Today I want to talk about the PEL 103, some of the characteristics of it, and primarily the setup of the instrument. PEL, or Power Energy Logger, model 103 from Aemc Instruments, is a rugged, installer-friendly instrument capable of performing power load studies, as well as voltage monitoring or energy efficiency studies. PEL 103 is a three-phase ready instrument capable of recording voltage and current both on AC and DC systems. Now, we get a lot of questions at Aemc about the current inputs, which there are three of. There is not a fourth input for a neutral current recording. That's because the instrument is capable of simulating that channel on most electrical hookups. With 4 strong magnets and a slim form factor, this instrument can be installed in a variety of different applications. And if we're working in an area where we can't attach it using the magnets, there's an included door hanger available. The bright display on the front panel of the instrument allows it to be used essentially as a 3-phase multimeter. We can install this instrument in a location where we can see in real time what the measurements are from the instrument at a safe distance. Now, we recommend that you set up the instrument initially using the PEL control panel, which is a free software available with the instrument or could be downloaded at aemc.com. However, if we need to change part of the configuration or start and stop a recording, that can be done straight from the front panel of the instrument. Also, we can lock out the control button of the instrument so it cannot be tampered with during a recording. The PEL 103 ships as a kit and includes 4 voltage leads as well as alligator clips and 3 10-inch mini flex sensors. Now, those sensors may not be long enough or applicable to your installation. Just know that you have a full line of power energy logging sensors behind you. You can find different sensor options at aemc.com. The PEL's battery is meant to be a ride-through only battery and should not be used to power the instrument during a long-term recording. We can power the instrument using a service plug nearby, or we can use the phase power adapter that plugs in to the top of the instrument and allows the instrument to be powered by the phase that's being monitored. So let's jump into the setup of a PEL. Today we're going to set up the instrument for a simple 30-day load study. However, I'm going to touch on some other features that may be of use to you in your use of the PEL later on. I've already downloaded and installed the DataViewPEL control panel. This software package is entirely free and can be downloaded from the aemc.com website or from a flash drive that's included with the instrument. Once the software is installed, connect the instrument with the USB cable. Once the PEL control panel is installed, open the application. Since this is the first time we're connecting to the PEL, we need to add the instrument to the control panel. Click the Add Instrument icon. The Add Instrument wizard will appear. First, we're going to select PEL 103 and click Next. Next, we're going to select USB and click Next again. The instrument should automatically populate. If it doesn't automatically populate, click the Show All Communications ports. Here I can see my instrument has already populated, so I'm going to go ahead and click Next. The instrument wizard has made a connection with the instrument. We'll click Finish, and now we can see the PEL information displayed on our screen. The next thing we're going to do is move on to the configuration of the instrument. You'll see a little wrench and screwdriver icon that says Modify Instrument Configuration. This appears in a few different locations on the screen. Now we're at the configuration screen. Notice the navigation tabs at the top of the window. These allow us to move through the configuration of the PEL in different steps. We're on the General tab first. On the General tab, we can create a name and a location for the PEL. These identifiers will appear on both recorded data and in future reports. You can create a name that suits your needs for the PEL, as well as a location. Both of these boxes are optional and they do not have to be completed for the PEL to record. The auto power off function will power the instrument down after the selected interval if the PEL should experience a loss of power. Disabling this feature allows the PEL to operate as long as the internal battery has enough charge, which is about 30 minutes. Next to the power off selections, we can adjust the screen brightness and contrast if needed. Other functions on this screen allow us to lock out the control button on the instrument, require a password to configure the instrument later, and most importantly, the internal clock synchronization. We suggest ensuring the clock is synchronized before every recording. To do so, simply press the Synchronize with PC clock button. The Communications tab is next. Select it to configure the Ethernet port or to enable and disable the Bluetooth connection. For our load study, constant communication with the instrument isn't necessary, so let's move on from this tab. The Measurement tab allows us to select the correct electrical hookup for our monitoring project. Here we've selected 3-phase 4-wire Y. I can see the correct orientation of my sensors and how they should be installed on my panel. Make sure that you can install your sensors with the arrow pointed towards the load, as pictured in the diagram on the screen. I can also configure voltage transformer ratios below the electrical hookup selection. This would allow me to monitor voltages in excess of 1,000 volts, usually associated with medium or high voltage. I could use a PT or a CT in this case. The Current Sensor tab is used to set the maximum range that our sensors are going to be monitoring on the current side. Select the appropriate range and if there are going to be more than one wrap around the conductor that you're monitoring. The Recording tab allows us to configure the recording parameters. Here we can set a session name, which will become the file name of the recording. Next, we can select the recording period and schedule. We will schedule our recording to start and stop at specific times if that's applicable to your recording project. This can be helpful to control the amount of data that is produced, or if you're using the PEL to capture usage or monitor voltage levels during specific times of the day. We can also start a recording now by selecting the Record Now button. Another way to start a recording immediately is to press the control button directly on the instrument itself. So I could pre-configure the instrument, take it to its intended recording location, install the sensors, and start the recording directly on the front panel. A new feature to the PEL control panel is the 30-day load study selection. When I click this, it automatically configures my aggregation period as well as selects the next hour for the start time of my recording, as well as sets the duration to 1 month. This function could be very helpful for those of you performing load studies according to the NEC 220.87 requirements. If not performing a load study, we can set aggregation periods, which selects how often the instrument averages and stores data over a defined period. For example, a 1-minute aggregation period for voltage on phase 1 would produce a single value representative of the average voltage for a 1-minute period. For the PEL, an aggregation period can start at 1 minute, maximum of 1 hour. Below aggregation, we can also enable 1-second trends for our recording. 1-second measurements will appear in a separate stored location in our data file and provide significantly better granularity for troubleshooting applications like measuring longer lasted voltage disturbances. Like the aggregation period, 1-second trend recordings will be an average of the measured values for a 1-second period. Here I've selected a 1-minute aggregation period and 1-second trends to be recorded. Lastly, I can choose to record factorized harmonics in 1-second periods as part of my recording. Note that enabling both 1-second trends and harmonics increases the utilization of my SD card significantly. Aemc only recommends enabling these features if they are needed. Since we're configuring our PEL for a 30-day load study, I'm going to simply select the 30-day load study function and click OK to save my settings. Once I've clicked OK, the PEL control panel is going to synchronize the data inside the PEL with the control panel configuration, and I should be ready to start my recording. Note that when I use the 30-day load study function, it selects the next rounded hour to start the recording. The control panel not only displays the instrument status, but also real-time values are displayed. A great control panel feature is the phasor diagram. The phasor can be used to troubleshoot my current sensors and voltage probes if they're oriented wrong or installed out of order on the instrument. The phase order light indicates that there is a potential error with how the sensors are hooked up or the phasing of the panel or system that's being monitored. If you see this light flashing, simply observe how your sensors are installed and correct the issue if necessary. Also, it's worth noting that sometimes this light will flash if there's not enough current present on the sensors. RMS data is also available for my voltage, current, and frequency, plus all my calculated power quantities can be displayed in real time. I can quickly check to ensure my phases are equally balanced and I have acceptable power factor on my system. That's it. My PEL is recording, my values look acceptable, and we're ready for the next project. I hope this video helped explain how to set up the PEL 103. For more information on our instruments, or if you have other suggestions on other videos we should make, check out aemc.com or shoot us an email. I'm Greg with Aemc Instruments. Measure up.